Okay, so we are in 5C. This is the last section we're going to cover. And so we got this 2 more classes, basically this class and then a test. The quizzes to help you with the quiz 5 is up. What else? Any questions about what's coming up? So we got a test next class, and there is a research project due. There is a quiz due that day. And I mentioned it, but previously I kind of allowed late work a little bit. I usually cut it off after the test. If you were submitting stuff after we took a test on it, I probably didn't take it or grade it. So with that said, this is the last week. Things need to get submitted on time this week. I'm not staying around grading stuff. Grades are due. I don't know when grades are due, but I'm trying to get grades in probably by the end of this week. I should get everything graded and turned around. I think everything's pretty much set up other than that. I just got to get a lot of grading done. So any questions about anything class-wise? If not, we'll go into more, I guess, content-wise. We did 5A. 5A, we introduced statistics. We talked about samples, population, sample statistics, population parameters. We talked about experiments versus studies, observational studies versus experiments. So experiments, they have controls and variables. And you proactively do something to make things happen. So you assign medication and placebos, or doing something along that lines. You're actively doing something in an experiment. Studies, you're just observing. So if a study lines itself up like an experiment, then it's called a retrospective study. What else would you do? Single blind, double blind is also in that section, I believe. What else did we do? 5B, is that what we did last time? 5B was about what?
5B, I think, was does this make sense?
Oh, yeah, the 5 criteria. That's what it was. There's was it 5 criteria? How many criteria was it? 8 criteria? I think it was 8.
I think it was 8.
Yeah, there's 8 criteria for judging a study to see whether the study was credible. So we're talking a lot about biases and things of that nature. So that's the section you're going to have to write some English on. So you write some sort of statement that convinces me that you know what you're talking about. So I know it's probably a dangerous thing to say, but I'm not sure how to be more specific. Being able to communicate is part of every study, right? It's part of math too. So I'm not sure, other than if you're not understanding it, then you need to ask questions, right? So if you understand it, you should be able to write me a sentence that shows you understand it. So we had those 8 criteria. I don't want to go through all of those, but there's 8 different criteria. And then today we're going to do some, what have we done? Frequency tables and histograms, a few different graphs, right? Graphs and tables. So I think we already talked about frequency. Did we talk about frequency and relative frequency?
I don't remember.
I think we did when we did probability, right? That's pretty much the same thing as relative frequency. So we're going to talk about frequency, relative frequency in this section. So this is what, some sort of, I don't know, scatter plot with what, temperature and cells. And then they do this thing where they find a line of best fit. So there's this big fancy word called regression. So if you hear linear regression or something like that, it just means that you're finding the line of best fit. It's not anything too crazy. Okay, so make frequency tables. Make frequency tables for the following data sets. Include columns for relative frequency and cumulative frequency. I don't have this lined up. Do I have this just a solution? Oh, no. I have the blanks on here. That's right. So we want to make a frequency table. Do you think you can do this? Is this something that's doable? So how many A's do I have?
6.
How many B's?
5. Wait, no, 6.
3, 6. That's it. Yeah. How many C's?
10.
3, 6, 9. Yeah, I think that's 10. How many D's?
5.
And how many F's?
3.
3.
And if we want to check this total should be, well, they tell us there's 30 students in class. So if we count up all these, hopefully we should have 30 grades. Do we have 30 of them? 12, 22, 27. Looks like it. And depending how you want to do it, I would probably start out with frequency, but you could also do totals, right? So totals, if relative frequency is kind of like probability, what should our relative frequency add up to?
30.
I'll give you that for cumulative. Whoa, what is that coming up? Don't come up. I'll give you that for cumulative frequency, but when we do probabilities, they go from 0 to 1. So if we add everything up, these should add up to 1. Okay, so we know there's 6 A's. So if I want to do the relative frequency of A, that's how many out of how many?
6 out of 30.
Yeah, 6 out of 30. Why are you in chat? Okay. And if we reduce that, I think it's what, 1/5? So you reduce it. You can write it as a decimal. I don't know how you want to do it. Was that 0.2?
I think so.
Same thing here. We still have 6 of them out of 30. This is what, 1/5 or 0.2? And I'm going to write it as the fat fraction first. 10 out of what, 30 is what, 1/3 is what, 0.333 repeating. So we talked about relative frequency. It's how many times this thing occurs out of the total number of occurrences. 5 out of 30 is 1/6. Is that what 0.66? Is that what I'm thinking? 0.16, right? Oh, is my calculator dead? One six is 0.16. Yeah, that's what it is. 0.16 repeating. Oh, 0.16 repeating. I guess we can go 0.17. Let's do 1/7 here. And we'll round this to point. Oh, don't do that. Do the select. I think if I just go 0.33 here, it will probably do what I want it to do. This is what, 3 out of 30? Is what, 1/10?
Yeah, 1/10.
Oh, 0.1. So if I add up this left side, I'm going to go at 6/30. This is why I wrote things and kept them kind of like in the unreduced fraction. 6 out of 30 plus 6 out of 30 plus 10 out of 30 plus 5 out of 30 plus 3 out of 30. What I'm doing is I'm just adding the numerators and keeping the same denominator. So I should end up getting 30 out of 30 on that if I add up these things. So I can add up the fractions with the common denominators. I should get 1. 30 out of 30 is 1. 30 divided by 30. Or I could add up these. So if I add up 0.2, 0.2, 0.33, 0.17, and 0.1, does that add up to 1? Oh, no. You're somewhere else. I don't pick you up no more. I was typing stuff away in. Okay, so this is what? 0.2 plus 0.2 plus 0.33 plus 0.67. So I did round a little bit. 0.17, sorry. 0.17 plus 0.1. Yes, I'm getting exactly 1. Sometimes you might get like 0.99 depending how you round these things. Sometimes we get those repeating numbers and stuff. All right, so the last thing here we got to do is what? Cumulative frequency. So what's my cumulative frequency for the first one? Do you all remember what cumulative frequency is?
Not really. I'm like trying to rack my brain.
It's where it's where it accumulates. So we start off with 6 A's. How many grades do we have?
6.
Yes, yes. Now we add 6 more B's. How many total grades do we have?
12.
12. So they're accumulating each step. So 6 and 12. And now I'm adding what? 10 to go to 22. Now
Okay.
I'm adding
5, 27.
27. Now I'm adding 3. Actually get to 30. And something you might want to take home on this is like you'll get 30 here, but you also get 30 in the one right above it. So this is where they accumulate. Cumulative. Yeah, we did our first table. How about that? Questions about this? Do y'all think this is something that is doable? Is that a qualitative or a quantitative variable that they give us?
Quantitative?
Ooh. Okay, so quantitative would be a number. Is A a number? It represents maybe some categories of numbers, but if they're giving us grades in A's, B's, and C's, this should be qualitative. They're giving categories. If they're giving us a number like a 98 or a 73 or something like that, that would be quantitative. So it depends how they're giving it. Questions on this? I think I have this on the next slide too, maybe filled out. I don't know if I filled them out or not, or if I just said I was going to fill them out. I did like this and I did the quiz, and so I don't remember what I did. The eye color of students in class, is that qualitative or quantitative? Oh, come on, fools. This should be a 3-second one. We're talking about colors. Is that qualitative or quantitative? Who's falling asleep? I hope this is one big tower of green. I really hope so. If you're talking about eye color, you cannot give me, you're not giving me a number to talk about the eye color. You're giving me a red, a blue, a green. Oh, it should be qualitative. It is not a number. So if it is a quantitative, it should be a number. I should be able to do things like put it on a scale, right? Put it on some sort of scale, I should be able to do things like average those numbers, right? If you're going to average red, blue, green, I don't know what you're doing. I should be able to do operations with it, like I can do with other numbers. So home prices in a small town. Is this qualitative or quantitative? This, they are going to give me a number. It should be quantitative. Oh, why is there one person saying the hump?
I clicked too fast. I misread.
Oh. Okay.
My dyslexia kicked in and it's like, nope, it's flipped.
They do look really similar in like the way that they're written. Quantitative. Okay.
Quantitative.
Never mind. I'm not gonna. Never mind. I thought about how to describe that difference, and it was probably thoroughly inappropriate. Okay. So annual salaries of NBA basketball players. Oh man, this is gonna bring some new jokes into my personal life. Is there one person who fall asleep? What was it? If you're talking about salaries, you are giving me a number for their salary. You are giving me a money amount that is a number that is a quantitative variable. Yeah, and it really like depends how they give you the variable, right? Because like in the earlier one, they said eye color. And so if you're talking about eye color, you're probably going to tell me like red, blue, green or something, right? You're going to give me the colors, right? But in reality, I could give you like, if you know how colors are, how we interpret colors, right? I could give you the nanometers of the wavelength, right? And these would be actually like kind of telling me the same thing. Like if I have a wavelength of certain nanometers, it's going to be red. If it's larger, I think it's blue. Is red the smallest? I think red, blue, red, green. That's not even in Roy G. Biv order. But the wavelength of it is what determines the color, right? So if I gave you a number for wavelength, a lot of these things you can express as one way or the other. But it's more, you have to look at what they're asking and how they're asking it, I guess, right? They're not asking for wavelength, they're asking for that. Okay, so most populous countries, the following table gives the populations of the five most populous countries. These are 2016 estimates. Make a bar graph for this data and with the bars in descending order. Did I do this? There we go. Bar graph. So what do I need on my bar graph?
Your X and Y axis?
Yes. I need, well, important, like I need labels for those and I need put things down. Yes, absolutely. Is there a way to make this bigger? Is that better? That's probably better to write on. I don't know if I left myself enough space down at the bottom now. I'm like gonna have to ink. Oh man. I was hoping to annotate on this thing and it worked. Maybe if I shrink it. Why does it look so far up now? Now, if I annotate, now that's a little better. There we go. I think this is what I want. Is there a way? Can I hide this thing? My taskbar is getting in the way now. There we go. That really works. Okay. So I hope y'all can see everything I'm writing. So I need labels for my axes. I need, what do I need? Population and country. And I probably want to say something about this thing is the world population. Something like that. World populations, populations of different countries. Something along those lines that describes what I'm looking at here. Down. So what am I writing on my y-axis? What variable should this be?
Population?
Yeah, this should be population over here. Okay. So I have 1, 2, 3, 4, 5, 10. I have about 15 lines, and I need to do about, what, 1,500? I probably should go to 1,500, I think. This is going to 1374. If I do 1,500 by...
Wait, should we add in millions to the population label? Because it says in the table, population in millions.
You should absolutely do that. Population, let's just do this in millions. So good call. And so if I'm going up to what, 1,500, I think is what I probably want to do to this, because this is right at what, 1,400, and I got 15 lines.
Yeah, maybe 14 or 1,600.
Yeah, well, if you do 1,500, it divides evenly by 15. That's what I was thinking.
Oh, okay.
It would be 100 for each line. So I think this is going 100. So I will do some of these. I don't know if I'll get them all. Come on, select. This one right here would be what, 200. This one right here would be 300. 400, what, 500. I think this is the 1,000 one up here. Does this space evenly if I do it? I think I did it to where it spaces pretty evenly. Maybe not quite. That's too much. Okay. My 800 is starting to come off. I think I might start skipping a few. This is what, 12. I believe this is what, 14. So it is a lot easier to pin these things in than to write them on an annotation. So probably throw in all your numbers in there if you have got this printed out. Make it look pretty. I didn't leave myself much room at the bottom, but down here it should say something about these are my countries down here. I know I did this, but like I piloted this out and tested it in their little test thing, but then now the margins are different, so I don't know. But we will do it anyway. This is what, China here. So I want to leave a space between each bar, preferably if I can. India would be the next one. I'm going to abbreviate US and Indonesia and Brazil. Ui. Okay. And now I want to draw bars for each one of these. So China is at what, 14? Right below it. So not quite up to it. So I want to draw my bar. I want to probably shade it in and keep it a little bit below. That's 13. That's 1350. So somewhere maybe like right in, I don't know, there. Same thing with India. It's 12. 1267. So this would be 1200. This would be 1300. So somewhere about in the middle of that, maybe a little higher than the middle. So not going to be like exact if you're doing this by hand, right? There is software that you can use that will do this for you. You can do Excel, right? Excel's got a lot of good sort of charts and stuff in there that you can toy around with. It's pretty industry standard for a lot of things, I feel like. 321. So I think this might be part of the reason why they want us to do this. This is 3, this would be 350. 321 is probably somewhere right in here. Indonesia, 258. So somewhere about halfway between 200 and 300. Ooh, higher. Would be right in there. Does that look about right? Does this look? If I'm doing something wrong, y'all can yell at me.
That looks about right.
All right. Brazil is the last one. I feel like I need to scooch it over just like one little spot, like right there. This isn't too bad. It's got just enough room to put the little countries down there. Okay. So hopefully the other ones work. If not, we'll figure out something. I'll have to point. Brazil is 206, so it is just like right at that 200. It might even be like noticeably a little bit higher, but not a whole lot. It's just right there. And these are the what, 5 most populous countries that they said? So India and China have like, I think almost like 4, 5 times as many people as us, I think, as the US. Pretty steep increase there. Questions about this one? Does this seem like something that's doable? What to take away? You want to know how many numbers you're going here, right? And you want to divide it by how many lines you have here to know what your intervals are going to be. So knowing how to determine intervals so they look pretty, that's one of the things, right? This is a, I forget. I think they make a distinct, I think the book makes a distinction between bar graph, bar chart, and a histogram. Do you all remember that?
A little bit. My mic was muted.
Okay, so like the bar chart versus the histogram. So this would be like a bar chart because, and part of it's because this is in a category, right? This is categorical. It's a qualitative variable down here. If this was a histogram, this would be quantitative. We'd be able to put numbers down here. We'd be able to put numbers going up probably. Are there any questions about this, about how to make this graph, how to make this bar chart? I believe a histogram is a type of bar chart is what it goes. It's like a subset.
A histogram bar chart is pretty much a bar graph, but all of the bars are touching.
Yeah, you want to make sure the bars touch because this is a continuous scale down here on a histogram. It's going to be a numerical value. I think we do some. I'm pretty sure we do some. And if we don't do them here, we do them in the quiz. So definitely got to know how to do bar charts. Definitely got to know how to do histograms. Definitely got to know how to do these table things. Okay, carrying on. Where are we on? Slide 9 of, okay. Doing decent. All right, so what are we doing now on this thing? Cell phone subscriptions. Oh, man. It wasn't that long ago, man. I'm probably going to date myself a little bit. But I remember going camping with my parents, and like, it wasn't even like the Zach Morris brick phone. They used to have like these things called bag phones, and they were like really bulky. They were like this. They were like a bag, maybe like, I don't know, probably the size of a laptop, you know, about the same volume, maybe a little bit different dimensions. But they were kind of preferable because they had better antennas, if that makes sense, because it was like you get horrible reception, but you used to pay like 25 cents a minute or some crap like that. Like, I don't know if it's still a thing, but like they used to charge you per text message. Oh man, I racked up a bill one time when I was in high school still. Got in trouble. But yeah, cell phones are kind of, and being able to use a cell phone and not getting charged up the butt for it, you know, it's kind of a modern sort of recent thing that happened. Relatively, I guess, right? You know, like, this guy's old. The following table shows that the number of cell phone subscriptions in millions in the US for various years. Construct a time series graph for the data. Does the graph show a straight line growth, linear growth, or is the growth faster than linear? The number of subscriptions, blah, blah, blah. The number of subscriptions can be larger than the population because you can have more than one subscription. You can have more than one phone. You gotta have that burner phone, I guess. I don't know. These are the numbers. Oh, this is how I wanted to do it. All right, so I could plot this on a line. That would be fine. But I think I want to do it maybe with some technology. You should be able to do this by hand, right? So we're going to do numbers in millions. We're going to do the year on the x-axis. So usually if you have a time variable, you're usually going to let that be your x variable. So if I want to do a table in Desmos, so Desmos is a good free software if you want to graph stuff. This is a good free software to do it. You can export the files. I use it quite often. But we want to create a table. So I believe my first thing is what, 1997. And I want to do the other thing is 55. So if you want to do this by hand, you can do this by hand. If you want to do this by technology, if you want to find some way or some technology to make this work, I will take that as well for this problem. I feel like getting a little bit practice of doing like both is good practice, if that makes sense. They don't personally, I don't think they personally want you to do this, but I feel like it's good practice. 55, 86, 128, 159, 208. You can do this in your, if you have a TI, you can do this in the TI as well. 255, 286. 316. 336 and 378. And you might type that all in. You might look at your graph and go, oh, shit, they didn't graph any of that. What happened? What do I have to do? Why is it not graphing it? Why can't I see it over here? and maybe it's a silly
Do
question.
you have to scroll up or zoom out or?
Yeah, you have to zoom out. It's not here. So the way that I would do it, and you can do this in your TI as well. If you have a TI, it works in the TI. You want to adjust that window somehow. So it's going to have an upper and lower bound on the X. So the leftmost I want to go with my X is probably what, 1990. Let's go 1996. Maybe go like one year before that. And in my X, it's going to go up to 2015. So I want to maybe go to like 2016, see if that works. And my Y axis, I'm going from 55 to, so I really want to start and do my first quadrant probably with my Y axis. I think I'm going to go from 0 to 378. Let's go 380 and see what it looks like. Let's go a little higher. Let's go maybe 400. Does that look better?
There we go. We can see it.
Okay. Now this is my line. Did they ask me to draw a line of best fit or something? Does the graph show straight line or linear growth? So does it show straight line or linear growth? That's the question. I probably should, with my annotation tools, I should probably come in and graph. This is what cell phone use over years. Cell phone subscriptions. So I should really put my labels in here. This is my cell phone subscriptions. This is my subscriptions in millions. Million. And this is the year down here. I don't have room done underneath it, but like pretend like I wrote this underneath it. If I'm doing this by hand, I should really put like a break in my graph. I think I talked about that, where it looks like I have my axis down here and I'd like put one of those little break signs in there. Because we're like skipping from 0 to 1996 here, right? So if you do it by hand, put your little break in there. Oh, it's getting in the way. Okay, so does this show straight line growth? That's the question. And maybe I should ask kind of two questions.
It seems like it shows a straight line growth.
Is it?
Couple bumps in the road, but
yeah, so there's a couple bumps in the road, but if I look at this, can you draw like that sort of line of best fit, right? Is what it's sort of asking. Does it look approximately linear? Yeah, it's a little bumpy, but that is approximately linear growth right there.
So it's almost like scatter plot in a way.
Yes, we're making a scatter plot. That's exactly what we're doing. We're making a scatter plot and we're trying to see what sort of pattern this looks like. So if I had more, let me like stamp more, draw a dot. That's what I want to do. Let me draw more green dots. So if I had more patterns that were, are you going to draw or no? Come on. So if I had like more dots down in here or something and it was like curving around, right? Those are horrible points, but I think you get the point. Then I would say that's not linear growth, right? This would indicate it's like way off. It is going pretty much approximately right there, right? And there's this thing, I talked about it earlier. This is what we call like linear regression, right? It's got a big fancy word, but if it follows a line, we call it linear regression. If it follows maybe like a cubic function, we call that cubic regression, whatever. Like whatever sort of function it follows, you put that function in front of the word and say regression. I think there's linear square regression. I think there are logarithmic regressions. If you're doing like viruses and stuff, we got to do a lot of logarithmic and exponential sort of functions to get at them. That and populations. Populations usually grow exponentially. So there are different forms of regression. This would be a linear because we're doing a straight line. It looks like a straight line. Another little maybe thing to take away is some of these are above and some of them are below, right? And so there's this thing that we do when we do linear regression. This is called the residual. And so if you notice, if we come up here and we subtract these two things, I think the residual would be positive. But if we do it from here, this would be like a negative residual. So we don't want to know like whether it's positive or negative. We want to know how far it is off of there to get the line of best fit. And so there's this other word you might hear the line of best fit called the least squares. And so where that comes from is that they're squaring the distance that these things are. And they square it to kind of negate the fact of whether it's positive or negative, if that makes sense. Because when you square something, it becomes not negative anymore, right? It's to get rid of the negative. So sometimes they will call this linear regression. They will call this the line of best fit. They might call it the least squares line. These are all things you might hear. I know that was probably a load, but any questions? These are things that you should be able to do. You should be able to do these by hand. You should be able to do these probably in some sort of technology at some point in your life, right? Okay. If there are no questions, this section is going to be a whole lot of, I hope they're listening. I don't know. Yeah, I don't need that. You're going to have to be able to do this stuff. I can kind of lead you, but like I can't really, it's hard to construct a quizzes question on it, I guess is what I'm trying to say. Can we do a scatter plot? So scatter plots is when we put the, did I talk about that? I talked about that, right? Scatter plot versus line graph. So the scatter plot is, that is not big. Can I get a bit bigger? Scatter plot is when we put our points on there, right? And then the line, this is one of those things that it is like, it is, what do I want to say? It is detailed exactly how you think it is. That is the scatter plot. When we start putting lines between our dot points, that is the line graph. So you should be able to do a scatter plot. You should be able to do a line graph. Okay. Electrical energy. The following table gives the percentage of electrical energy generated in the US from various sources. Display the data as both a bar graph and a pie chart. Then write a short paragraph discussing the pros and cons of each display in terms of interpretation. All right, so we want to do a bar graph. We want to do a line chart. Man, this is like cutting off. If I hide that, does it make it better? No. Okay. So if I go and I do, let me see. So I have these numbers because I don't have these numbers on here. So I got to go 5C is what we're in, and this is problem. I have too many little windows on my screen is like part of what it is. And I move this thing. It needs to be down here. Okay. So these things, these problems take a little bit of time, but the good thing is we don't have too many of them. So this is problem 33. Let me open that up in another screen so I have these numbers somewhere. 33 right there. Let me close this out to be small. Let me close this up here, and this one. Have my numbers here. So coal is 33%, natural gas is 33%, nuclear power is 20%, renewables is 7%. Do you want me to go back to that slide? Maybe that might help as well. So if you want, it might be beneficial to like sort of take a picture or jot these numbers down right quick. Oh man, when I created this, I had in my head, woo! Whoa.
Goodbye, camera.
Yeah, I almost dropped my computer. I think this is like wobbly. I need to fix this up. And we have to try to do a bar graph and a pie chart is what they want. %, what is that? What's the easy way to think about that if you're doing a pie chart? It's like what, a third? 33.33 is a third, 33.33 is a third. All right, so I'm gonna try to do it on this thing. I guess I can draw me a y-axis that's actually on here. That might be the thing to do, right? Just draw me a freaking y-axis that's gonna work. And so I need that, and I need, when I do annotations, I can't do, that's kind of annoying. When I do annotations, I like, it does weird stuff, I guess is what I'm saying. Have an idea. Don't laugh at me. Yeah, if I put this on my phone, then I can, if I do what I told y'all to do, then it might help me out. I have too many things on my screen. And so I think I'm back here. Annotate, draw a straight line across, I don't know, right here. Let's pretend like this is our new y-axis here, since I can't draw below that one. And I have 1, 2, 7, what is this, 12 things I can work with. I think I have a dozen there. And I have a dozen, and I need to get at, what's my goal? Oh, I'm doing 33. I'm doing percentages. So I need 40% at most, I think is what I need. I'm up at 33%. So this left side, I didn't leave myself much room, but this is what electricity usage by generation type, or whatever you want to call it. I don't know what they said in the problem, but that's what I'm calling it, something along those lines. This over here should be percent. I didn't leave myself enough room. But over in here, we should have this thing called percent. And I think if I just go by, I don't want to say it right off the bat. We're going to go by 40, divided by 10, go by 4 each line maybe. Where this is 8, this is 4, 8, 12, 16 here. Put 20 here. This is what, 24. This would be what, 28 and what, 32. And 36, I think, will get us to the highest thing we need. And so what did we have? We had coal and gas, both at 33%. So I want to do coal and I want to do gas. And I want to draw them to 33%, which is pretty close to 32, a little bit above 32. Here's my coal, here's my gas at the same height. What else do I got? I have nuclear power, so I'm going to abbreviate that with nuke. Nuclear power is at 20. Which is what, this line? The next thing we have is renewable non-hydro power. And so renewable, non-hydro, and then we have hydro. Let's extend this thing all the way so it doesn't renewable. And then we got hydro. So I'm abbreviating things because I don't have enough room. If you don't have to abbreviate things, like write the full word out there is my suggestion. Hydro, and then I think we got other is what they do. They just categorize. There's usually an other section. Like other things are so low, it's not even worth talking about usually. It's like, yeah, there are other things. But renewable, what was that at? That was at 7%. So right below the 8, I believe is where we're going. So if you were to do this, and we hadn't finished this, but what is the way you probably want to do this? Do you want to do this with a bar graph, or do you want to do this with the pie chart? What would be the advantages, disadvantages? 7, 6, and 1, I think is where I'm going. 7, and then this one should be a little bit lower. 1 lower. And then others like here, it's got 1. Oh, did this freeze? Weird. What's happening?
I'm scared that if you click restart, it's going to lose the progress on the graph.
Yeah, if it does, it does. Do you think you could do a bar graph like this?
I think so.
Okay.
I mean, we did one earlier.
Yeah. This should be doable, hopefully.
Yeah, I could.
The other thing is this pie chart over here, right? No, like my whole screen is frozen. Like my annotations, like the zoom is frozen. Oh no, there it goes. I don't know what I clicked on. Okay, that is freezing it up. I see what's happening.
Okay.
Maybe. Do I see what's happening? Is this picture?
Oh, it's a connection thing.
No, it's like something with the zoom.
Oh.
In this picture I was like bringing up, it did something weird. All right, so I think I can do it without. I know it's frozen. Y'all can see the screen, right?
Yes, we can see it.
All right. So that's the important thing. Coal, and I kind of said this, coal and gas. That's probably what I'm going to start out with. If I want to draw it, this is what I'm thinking. And it's going to be like, it's going to be hand drawn or whatever the heck you want to call it. It's kind of hand drawn on here. I'm thinking of about a peace sign. That would be equal thirds, right? So if I peace sign this thing out, peace, I come down here, try to get it into the center, try to do this little peace sign thing. I think this will give me 2 sections here, right? And so this would be what? Coal. And this is at 33%. This would be gas. It's a gas at 33%. So I divide it into thirds. That should give me the 33%. And then how am I figuring everything else out? You could also do 33% of the full circle is what, 360? So if we do 0.33 times 360, I want to do calculator. Come on, calculator. 0.33 times 360, that is a what, 118.8 degree line. If I wanted to measure this thing, that's probably not the best way to do 33%. 33.3 is a third. I would say that they're pretty close to being what, a third of the circle. The nuke is 20%. So if we do 20% of 360, that is what, 72 degrees? So what's a good way to think about that? That's what, 60, somewhere between 60 and 90, I think is a good way to think about that maybe. So going what, 2 o'clock, I think is 60 degrees. If you think about a clock, each number is 30 degrees, right? We go 30, 60, 90 degrees would be 3 o'clock. From 12 o'clock, from the 12 to the 3 is 90 degrees. So we want to do this with somewhere around, I think this is going to give me 72 degrees. So if I wanted to do 33% of 360, that would give me the number of degrees it is if I wanted to really do that. 72. So I can multiply the percentage or the frequency by the 360. It should give me the number of degrees each one of these things is. And again, if you're doing these by like hand, I think I said this in the notes, this is 0.07 times 360. What it was, 7? Yeah, and the next one's 6%, right? You could do this, but we're kind of guesstimating these things, right? We're doing them by hand. This is somewhere around 21.6, I think is what I get. So using things like 25% would be what? A quarter of this thing. 33% a third. So if you can divide this into quarters, into thirds, 50% would be a half. That might also help you get these degrees, right? Knowing these common, what do you call them? Percentages. That gives me 21.6. What does the 7 give me? 25.2. Okay, so trying to guesstimate these things as good as possible. So it looks like this one probably needs to be about double of those other two. Or maybe a little bit more, right? So I'm thinking maybe something like that. I don't know, something like, I need that little really one small, like what, 1% thing there. And these two are about equal. So this is a pretty rough sort of thing, but I'm not expecting anything exact. So we got coal, gas. This is my nukes at where, what percentage was that? 20%? Yeah, 20%.
I think it was 20%.
Yeah, it says it right here. And renewables. So there's probably not enough room to write renewable. But if there's not, You can always do one of these little numbers. You can do this, and you can point. And that is, I probably should put the percentage just to keep it what I've been doing. Non-hydro is 7%, and the next one is 6%. Move out of my way. This one is hydro. What do they say? Hydroelectric. Oh. Hydropower is what they call it. Okay, let's keep their I guess verbiage. Hydropower. This is 6%. And then I'm going to put other 1% way over here. I don't feel like making a new box. I'm just going to put it. Actually, I should move this over a bit, huh? Let's move it all over a wee bit. I know I'm probably taking a little while to do this, but I'm hoping y'all are working along with these, and hopefully you can get your homework done for the most part in class, right? Okay, so one little thing I probably need to do is I probably need to put this title over here. I need to have a title for both of these probably. I could put the same title as they're both measuring the same thing. So which one of these, if we were going to talk about energy usage within the US, which one of these, can I just like delete this? I used that already. So which one of these would you rather look at? Like which one, what's the advantage of looking at one versus the other? If you were to have a presentation, you're going to present this to the company you work for. I should really have a title down here, right? Type of generation. I think I missed my X-axis title for my bar graph. So definitely label it overall, label your axes when you do a bar graph. I'll be like not quite so lazy and write this out twice, I guess. But like, what is the benefit of having one versus the other? If you were to do a presentation, which one would you pick, and why?
I would probably pick the pie because it has the numbers like a little easier to read to me.
Mm-hmm. No, I think that makes sense. I think this one makes a little bit more sense, just personally. And why am I going to say that? Can you read my mind? That's my question. Pie graphs are really good at get parts of a whole, right? So we have electricity usage within the US. We have this whole thing that we want to talk about, which is the electricity that we use. All right, so what is generating? What parts are generating what parts? If we look at it like this, we can see that coal and gas and nuclear power all take up a really big portion, right, of how much we're generating. If we look at it like displayed out like this, you might be able to tell like there's significantly more. But visually, I don't think it's like as appealing, right, as like this. This, I can really see that they are parts of a whole. Here, it's not so obvious that that's what we're doing. So anytime you're doing parts of a whole and all these things make up one thing, right? When we add up all the other power, the hydropower, all these different powers, we get the whole power within the US. We are talking about a whole thing. And so generally when you're talking about parts of a whole, that's where you want to use these bad boys. So that's what I would say personally. Does that make sense?
Yes.
Yeah, you can see the whole pie, right? The whole pie being electric. All right, so we got one more, I believe. Okay. Age of Nobel Prize winners. They drop off after you get to 89. Look at that. I guess no one older than maybe, I don't, maybe they're just not included on this. But it doesn't look like anybody older than 89 got a Nobel Prize. I talked about it, but they don't give away Nobel Prizes in math. Nobel Prizes, I believe, are for like applied sciences. And so math is the mother of all sciences, right? It is not an applied science like the other, like chemistry and physics are. And so what they give in math is called the Fields Medal. That's kind of the Nobel Prize equivalent. I don't like the way they did this because they just say under 50. So in order to make things easier, I think we're just going to make our chart. And it's going to throw it off a little bit. What is this, 45 to 49? We're going to make it so it's 45 to 49 because it makes it easier to make the chart. It is not reality. We're going to bend reality to make things easier a little bit, I think. We want to draw a histogram. So now we're drawing a histogram. Write a shorter paragraph explaining any noticeable trends or patterns. I believe I have my setup on the next page to draw this histogram. If I get out of annotations, I can click on the next arrow. There we go. If I go back to my annotations, I can move this up. Ah, come on. Not you. We're going to pretend like this says 45 to 49 here. Will that thing hide if I get this thing? If I full screen it, will it hide? All right, so we want to be careful. If I'm drawing this, I should probably put my little, I want this thing out of here too. This thing needs to come up top so I can write on bottom. Okay, there we go. Did that move? Why is this moving around? Okay. So I think I might have enough room down here. Can y'all see that down there?
The 45?
Yeah.
Yes.
Okay. So there should be technically probably a line break in here somewhere. So I think we're going to start with what, 45. We got to work our way up to 90. Is that what we're doing? 1, 2, 3, 4, 5, 6, 7, 8, 9. There needs to be 9 different bins. I think we can maybe do them by 2. So we're going to go from 45, and I think this one will be what, 50. This one will be 55. This one will be 60. This one will be 65. Am I skipping one each time? 5, 60. So I know I'm a little cramped here. I swear when you do the like practice presentation, they do their spacing different. So it's like, I don't know why they do that. That's kind of annoying. I think we got to go up to 90, I think is what we're going to. From 45, we're going up 5 each time. So you might notice each bin is about 5, right? We're going from 45 to 50 to 49, 50 to 54. And I talked a little bit about it, but this includes 45, 46, 47, 48, 49. So there are 5 different numbers in there, I believe. This includes 50, 51, 52, 53, and 54. So it's like you have to count the endpoint you're starting on, but it should give you 5 different numbers. This should give you 5 different numbers. And so I don't have much room, but what should I have down here? This is saying the what age in years. This is going to give me the number of winners on my y-axis. And so in my numbers of winners, I have to go from 1 to, I think up to 18, 19, 20 probably is where I'm going to go. This is 5, 10, 15. I think I'm going to have to go by 2 each time. 1's not going to get it. 2 will get it and get me some change there, I think. So 2, 4, 6, 8. This would be 20 then, right? Did I space these out correctly? 2018. It'd be what, 16 and 14. See, I had this spacing down too. I resized this so that it would be spaced perfectly, so it's like really smooth. And now they changed things around on me. But I think we'll still have enough time to get this done. 12, 10, this is what, 8, 6, 4. Okay. So we want to do a histogram. So in the previous ones, I had bars that didn't touch. And this one, guess what I want to do? I definitely want them things to touch. So
I was about to say, I just didn't click the mic in time.
Yeah. So 45 to 50, I want to go to 9, which is between what, 8 and 10. So right in here. 50 to 55, I'm going 50 to 54, right? This one, I go 45 to 49. It hits the 50, right? But the 50 isn't actually included in that number. It's included in the next bar. So the number that we go up to, this one's included, right? But the next one, the 50 wouldn't be included here. The 50 is included here, but the 55 isn't included in it. So it only goes up to 54. Same thing here. So we're not including the number it goes up to on the bar, if that makes sense. So these things should definitely be touching. 50 to 55 is what, 10? So I should have 10 here. The next thing is 55 to 60 should have 18. So you might see a little bit of a gap in there. That's because I don't know how to draw stuff on this computer. There shouldn't be any gaps between these bars. 60 to 65. I have what, 18 again, and then it goes up to 19 in the next one. And 19 on the next one is right in there. And then we go back to 18 for 70 to 74. And we go 15 is the next number I'm looking at. 75 to 80, 75 to 79. 15 would be between 14 and 16, somewhere in there. And 80 to 84 is 4. And now we are going where? 85 to 89 is 2. Okay, what do we want to notice about this thing? What are they trying to get you to notice? Let's do this in pink.
It varies a lot by age.
Yeah. Do you notice anything about the shape of this graph?
It's kind of has a what's it called? A bump.
It's got a bump.
It looks like a mountain.
Oh,
it's got a mound.
What was the name? It was like a uni something.
Modal?
Motos. Ah, man, what was it called?
Sometimes it's called unimodal, sometimes.
Yeah, that.
Yeah, so it's got one number that it's really centering around. So most people are between the age of what, like 65 and 70, right? 65, 69. It starts like weaning out, going down this way, right? And it really, this one is probably taller than it should be, right? Because we included a lot of ages in here. This should probably be like smaller and smaller eventually, right? And there might even be a gap and then like one over here for someone really young that got it. But it's got these legs coming off of here. What do I want to say? I think I talked a little bit about it. If it's like uniform, right? That would be like the standard normal curve would be like that. If it was more uniform, you get this sort of thing. If it's got like this sort of shape or it's got a long leg going off to the right, we might call that right skewed. If it's got a long leg going off to the left, we might call that left skewed. This is pretty centered, right? I think fairly centered. It's fairly centered about like this age. So this is telling me that there is probably like an age, particularly between what, 65 and 69, but moreover, like right in here from the 55, probably to the 80, right? So from 55 to 80, that's going to capture like probably most of them, with most of them being right in the middle of that from 65 to 69. So the average age is probably like 65 to 69. The thing about this is we don't go into averages or means or medians or modes. Those are all measures of what they call central tendency. And when you get something that is equal, like the normal curve, your mean is going to be equal to your median, right? Is the word I'm looking for. So your mean is when you take all your numbers, you add them up and you divide by the total number. That's your arithmetic mean. That is the thing that you're used to talking about when you talk about the average. It's the arithmetic average. Your median is when you take your numbers. I can't believe we haven't done this. And we're doing statistics. You line them up in order. 12, right? And let's just throw in 1,000 just because. And so your median is when you take your numbers, you line them up in order, and you start crossing them out to find the middle number. And so when you have something that is normally distributed, this is why we like normal distribution. So the median of this would be 4. When it's about even like this, your mean is equal to your median. If you have something like this, let me think about this. You have really. I think this is going to make your mean larger than your median. They're not going to be the same thing, right? It's going to throw your mean off because your mean is really responsive to these things that we call outliers. So here my outlier would be like 1,000. So if I think about adding all these numbers up and dividing them, I'm going to add 1,000 in there. It's going to create a really, really high number. You know this if you've ever been like an all A student and you get 1 0, that 0 is going to really throw off your grade really bad, right? You're going to get all these A's, you're going to get a 0, you're probably going to get a B in your stuff. It's like you did all that work and then you messed up once. So this goes back to like why we like things symmetric. We like the normal curve because it is symmetric. It's going to make our mean equal to our median if it's exactly normal, which you almost never get. But there's reasons why we got multiple measures of central tendency. And one of the faults of the mean is that it's really responsive to these things called outliers. And so if we throw in a really big number or a really small number, does that represent our population? Maybe there's a 5-year-old over here, right? That got, there's some shithead 5-year-old that got a Nobel Prize, right? I don't know. Does that mean that the average Nobel Prize winner is 5 years old? No, that's not what that means, right? That's an exception to the rule. So we'd probably want to talk about the median age of them. And so this also comes up when we talk about like incomes, right? When we talk about median incomes versus mean incomes, there's a very select few people that make a lot of money. So it makes more sense to talk about the median income a lot of times than to talk about the mean income, because the mean income is going to be a lot larger because of people like this. The few people that make a lot more than everyone else is going to make that mean look a lot larger. So any questions? I know I went over, like, just threw it at you right there at the end. I think the thing that they want you to notice here is that most people are lining up around this age gap, right? And then we start getting this weaning off. Like it starts going down pretty quick here. It starts going down pretty quick here. So there's mean, there's median, and then there's mode, which is the most used number. And since the number that you use the most is your mode, those are basically the three measures of, central tendency that they talk about. That is the last problem, ain't it?
That should be the last problem.
Yeah, y'all got questions about this? Do you think you can create a histogram? If I give you a table like this, do you think a histogram is doable?
Yeah, I think so.
I think so.
Okay. That's what I'm kind of expecting. So I think that's the last slide. I think we're probably right there on time anyway. I know we were like hitting it pretty close. Oh, I'm over time. Okay, that's it. That's all I got for you. If y'all got questions, don't forget everything that's due. I know it's the last week. Be busy, bees. I don't know what to tell you. You get a test, you get a quiz, and a research project, right? That is due. Okay.